Good day, students. You're welcome once again to Basic Science class. In the previous lessons or classes, I started on atoms, elements, atomic number, number of electrons, number of protons, electronic configuration, that is the way electrons are arranged in atoms of elements. So I do the previous class, that's the class before now, I summarized, but I just thought of it that let me bring out this electronic configuration and align it with the song, that memory song that I taught us, and make it bolder so that you can see what we are talking about. So I tagged this class electronic configuration. Electronic configuration just means the way electrons are arranged in atoms of elements. The way electrons are arranged in atoms of elements. Now we have 118 elements in the world today, but like I said earlier, that the first 20 must be mastered, must be memorized, must be known. Not only that you know the names, you must know the way they are arranged sequentially. And once you know that arrangement, the order of arrangement correctly, it will help you to know or deduce atomic number. It will help you to deduce number of protons. It will help you even with mass number. It will help you with lot of calculations in chemistry later in life. Apart from basic science, even in chemistry, it will help you. And this is what we did then that really helped us. And one of the acts that we used then was to form a song, which is like a memory song that tells us where each element falls in these first 20 elements, in the arrangement of these first 20 elements. Now, the song says, "Hello, hello, little baker, bring certain news of favor now. National manager always says, perhaps some chlorine are killing cats. Hello, hello, little baker, bring certain news of favor now. National manager always says perhaps some chlorine are killing cats. Hello, hello, little baker." Please sing with me. Bring certain news of favor now. National manager always says perhaps some chlorine are killing cats. Okay, this song is made up of 20 words, and we are talking about the first 20 elements. So once you know this song, hello starts with H. The second hello starts with H. And as you progress in chemistry or in science class, you'll be able to know all these elements that, okay, once I mention silicon is one of the first 20 elements. Once I mention aluminium, you will know, because by the reason of use and mastering, you'll be able to know. But where does each one of them now fall? That is where the work is. And what can really help you to really get it is this memory song. And that's why I brought it out boldly. And then I now merge it with the number of atomic number, the position, the atomic number, the symbol, and also the number of shells. So let's go. The first one is hello. See it, hello. Then I told you that the first letter helps us to know that hydrogen is the first element in the first 20 elements. So, or in the periodic table. So hello, hydrogen, that's hello. You know the song already. After mastering the song, already they are teaching you chemistry class or science class that the first 20 elements, like that. So once you know this song, once you say hello, your brain tells you that, okay, hello is hydrogen because it's the very first element in the periodic table. The next one, the symbol of hydrogen is H. All over the world, since time immemorial, is H. Then atomic number. How do we deduce this atomic number? Remember I said earlier on that once you know the atomic number, atomic number is equated to the number of proton. But aside that, this first element as hydrogen belongs to number 1. That means atomic number also is 1. That's another reason why you should know this song serially, so that it can help you to know the atomic, because you know all these figures, you need all these figures to do some calculations. Sometimes they can give you a question and they will just want to test whether you are very proficient in chemistry. They will not give you the atomic number. But once you know this sum, you know, okay, hydrogen is what they are talking about. Hydrogen is number 1. So atomic number is 1. That is, whatsoever you see, if your sum is correctly arranged, whatsoever you see as a serial number is going to be the atomic number. Remember, like I said, this memory sum is not part of chemistry. It's just an act that we formed to help us to remember the way elements are arranged in the periodic table, the first 20 elements. Now, atomic number 1, like you have a number 1, atomic number also is number 1. Electronic configuration, like I said, is the way electrons are arranged in the shells that surround the nucleus. Now, there are rules that guide this electronic configuration, and for the first 20 elements, this rule says that the first shell that comes after the nucleus of an atom can take maximum of 2 electrons. The one that follows it, which is the second shell, can take maximum of 8 electrons. The one that follows it, which is the third shell, can also take maximum of 8 electrons. Then anything that spills over now goes to the last electron, and to the last shell. Now, the first 20 elements, that's the maximum number they contain. That's the last one is calcium, which contains 4 shells. We get there. So don't let me digress. Now, LO, the second LO is number 2, according to the arrangement and the reading and the singing of the song. Then we all know that the second element is helium. Then the next symbol, the symbol of helium is He, and atomic number, since this one is 2, this one also is 2. Atomic number is, because it belongs to number 2, atomic number also is 2. That means it contains 2 protons and 2 electrons in a neutral atom, in a neutral element. Now 2. Then electronic configuration is also 2. Electronic configuration is also 2. I wanted to say in a neutral atom. Electronic configuration is also 2. Then remember I said it can contain maximum of 2 electrons. So we are still talking about one shell, only one shell. After nucleus is only one shell for these 2. Then look at it. The number of shells is 1. Then for lithium, that's talking about the third element, lithium. Li is the symbol all over the world. Then atomic number of lithium, since we have number 3 here, it's going to be the atomic number 3. Then the electronic configuration, the innermost shell which follows the nucleus, like we all know, takes 2. That means the next one, we are talking about 3 electrons here, because atomic number also is the number of electrons. 3 electrons, we have already taken 2 to fill the first shell. That means the second shell we occupy the last 1 electron, which now makes it 3. And the number of shell now has turned into 2, because the first shell takes 2 electrons, the one that follows it takes 1 electron. Okay, so we go to number 4. Our memory sum, element, symbol, atomic number, electronic configuration, and number of shells. That's what we have in this table. So let's go to number 4. Our song, Hello, little baker. That's baker number 4. Remember, we are following this series because it's going to help us to know the number of, to know our atomic number, also to know the number of electrons, so that we can distribute in our electronic configuration. So baker is number 4, and baker B represents beryllium. There's something that you need to commit into your memory in chemistry, in science, because like the first one is B, the second one is BB. So you're supposed to memorize it that beryllium comes before boron. If at some of these atomic number, over time you get used to them. At least you don't even need to trouble yourself. You just closing your eyes, you can just say, okay, boron has 4, beryllium has 4, boron has 5. But for now, just know that beryllium comes before boron. Another thing I used to do in my days when I was in school, I use a lot of methods to help myself so that I will not be confused. Like for example, you know that E comes before O in A, B, C, D, E, F. So when the thing wants to confuse me, I'll just look for a method. For example, now B and B, baker and bring, both of them are B and B also. So how do I know the difference? How do I know which one, which B, which element that starts with B will be 4, which one will be 5? Very simple. E comes before O, so it has entered my brain that I'm talking about 2 elements, beryllium and boron. So E comes before O, so beryllium will be the next one. Just the method that I normally use to help myself, this science, memorizing some of this science stuff. So LO little baker, beryllium, BE. That's the symbol of beryllium all over the world. And since this number 4, our atomic number also is going to be number what? It's going to be 4. And remember, electronic configuration, the way electron, atomic number also means this the same thing as number of electron in a neutral atom. When you get to chemistry class, they will teach you how to know neutral atom from the one that is no longer neutral. But for now, we're talking about neutral atom that is in a neutral state. Atom that is in a neutral state. So 4, that's talking about 2 innermost shell takes 2, the remaining one will go to the next shell. It means that, remember, the innermost shell contains maximum number of 2, the one that follows contains maximum number of 8, and we have not gotten to 8. We are still having 2, so we are having just 2 shells. Then the next one is bring. LO little baker, bring. So B, like I told you, the first B is beryllium because it comes before O. So I mean the second letter in the beryllium comes before the second letter in boron. So I know that beryllium is number 4, while boron is number 5. So the symbol for boron is B all over the world. And then the atomic number of boron is what? 5, just like we have it. Then that means the number of electron is what? 5. That means we are going to now distribute, or the electron will be distributed naturally in the neutral atom. So 2 will be taken by innermost shell, which follows the nucleus, and 3 will spill to the next shell, which is the second shell. So how many shells do we have? 2. So that's why we have 2 here. Then number 6, setting. LO little baker, bring setting. Setting is C, and we are talking about carbon. C is the symbol for carbon, and if C is number 6, that means atomic number, which is number of proton and electron in a neutral atom, is also 6. So that means the innermost shell will take 2, while the next shell will take 4. 2 plus 4 is 6. Remember, you can still accommodate up to 7, even 8, because the next shell can accommodate up to 8. The shell that follows these 2, that's the first one after the nucleus, can accommodate maximum of 8, and we are still talking about 4. So how many shells do we have? 1, 2. That means after drawing the nucleus, which contains the proton and neutron, then we now draw the first shell, which is going to accommodate 2 electrons. After that one, you can't accommodate more than 2 according to the rule. Then you now draw another shell, which is going to accommodate these 4. That's why we have 2 shells in that one. Then you go to news. Remember, chemistry, your WAEC, your JAMB, they will not ask you, give us memory sum. Nobody will ask you. I told you it's an arc. It's just a sum that we form to help ourselves to remember the way elements are arranged in the atomic in the periodic table. So news, nitrogen, N, nitrogen. The symbol for nitrogen forever is N. Then the atomic number is 7 because it belongs to number 7. It means that it has 7 protons, 7 electrons. But we are dealing with only electron for now. So 7 electrons. So the innermost shell will take 2. The remaining 5 will go to the next shell, meaning that we have just 2 shells in nitrogen too. In oxygen, that's the next one is LO little baker, bring certain news off OF. O there tells us that the next one we are looking at is oxygen. The symbol for oxygen is O. Then atomic number of oxygen is 8, meaning that oxygen has 8 electrons. So the innermost shell will take 2, while the remaining 6 electrons will go to the next shell. So how many shells do we have in oxygen? 2 shells. We have flavor and fluorine. And remember, fluorine is the name of the element that follows oxygen. Remember, oxygen was number 8. So our sun still goes thus. Hello, little bit carbon certain news off. That was when that's how we have oxygen. Flavor, F, fluorine. The element is fluorine. The symbol is F. The atomic number is 9, just like the serial number. Then the electronic configuration, the way electrons are arranged. The innermost shell we take 2, the next shell we take 7. 2 plus 7 is 9. Then the number of shells is going to be 2 because 1, 2. Then LO people have been certain use of flavor now, which is bring us to the 10th element, which is neon. Then neon is just like helium, is a noble gas, inert gas. So neon, the symbol of neon is Ne. Then we have 10 as the atomic number, which is also the number of electrons. Then the innermost shell takes 2. Then the next shell takes 8. That brings us to the end of atoms that have 2 shells, because remember I said maximum number of electrons that the second shell can take is 8. So you see what will happen to the next element now. So how many shells do we have? 1, 2, taking 2. Then let's go to the next element, which is sodium. National. Hello, little bit can bring certain news of flavor now. National is for sodium. But if you wonder how to be, sodium does not have Na. So where did he get the symbol? Because all the ones we have been looking at is either you take the first letter to represent the symbol, or they pick the first letter and one letter in the word. But this time around, Na is nowhere to be found in sodium. But don't worry, like I said earlier, Na is taken from natrium, which is the Latin name for sodium. So, and it's number 11. Now look at the electronic configuration. The innermost shell takes 2. The next shell takes 8. Then the one that follows it now takes 1. Meaning that the number of shells has changed from 2 to 3. 1, 2, 3. Because the second shell cannot take more than 8. And we are talking about 11 electrons. So if the innermost shell takes 2, the next shell takes 8, it remains 1. Those next one will now go to the next shell. Then we have 3 shells. Then we have little bit of certain use of flavor and national manager. We have national manager. And that takes us to magnesium. Magnesium is number 12, meaning that it has 12 electrons. Atomic number also is 12. And then the way electrons are arranged, there is 2 for innermost shell that follows nucleus, 8 for the next shell that follows that one, and then the next 2 goes to the next. That is, the remaining 2 electrons will go to the next shell, meaning that we have 3 shells. So the next element we look at is number 13th element. Number 13 element, which is aluminium. And remember our song, little bit been certain use of flavor. Now, national manager was the last one we look at. National manager always Al, aluminium, and the symbol for aluminium is Al. The atomic number for aluminium is 13. The electronic configuration of aluminium is 2. Innermost shell we take 2, next shell we take 8, and the remaining one will go to the next shell. So we have 3 shells. 1, 2, 3. Then number 14, national manager always says, that is silicon. Like the first method I use, this is silicon, this is sulfur. They are both SS. So you can now remind yourself in ABC, reading ABC or reciting ABC, I come before you. So silicon will come before sulfur. That's what I normally do to help myself in those days, to remember a lot of things so that I will not muddle things up. So always says silicon, then Si, then 14, meaning that it has 14 atomic number of 14. Number of electrons is going to be 14. 2 The innermost shell will take 2, next shell will take 8, then the remaining 4 will go to the last shell, which is going to be 4. How many shells do we have? 1, 2, 3. 3 shells. So silicon has 3 shells. Then we are going to the sum. Hello, little bit. I've been certain use of flavor now. National manager always says perhaps. When perhaps now, P, perhaps that's phosphorus, and the symbol for phosphorus is P. One atomic number for phosphorus is 15. Based on this serial number, then the electronic configuration, the way electrons are arranged around the shells of the nucleus of phosphorus is innermost shell will take 2 according to our rule, followed by the next shell which takes 8 electrons according to our rule. Then the remaining 5 go to the third shell, which now give us 1, 2, 3 shells. Number of shells for phosphorus is 3. Then according to the sum, little baker have been starting use of flavor. The national manager always says pass of chlorine. Sum, we are now in sum. Sulfur. S is sulfur. Remember, the first S is silicon because I comes before U. That's why it is arranged in periodic tables. But so that you don't model things up, just use all those acts, all those methods to remind yourself. Sulfur is the one that comes after silicon. That is, you call sulfur first as S before you call silicon. You call silicon first before you call sulfur because I comes before U. So sulfur 16, 2, innermost shell will take 2, the next shell will take 8, and the one that follows will take 6. That's 3 shells. 1, 2, 3 shells. Then some chlorine. Always says perhaps some chlorine. Chlorine is still chlorine. Chlorine, then the symbol for chlorine all over the world is Cl. The atomic number is 1717. Let's look at the electronic configuration. A chlorine cell.
Just start at sulfur.
Okay, so sulfur. The next one is the every have been certain use of flavor. The national manager will say perhaps some S sulfur. The symbol of sulfur is S. Then the atomic number is 16. It means that it has 16 electrons. It is 2, 8, 6. So the innermost shell will take 2, the next shell will take 8, and the one that follows will take 6. So how many shells we have? 1, 2, 3, 3 shells. Then that takes us to chlorine. Little bit of certain use of flavor. National manager will say perhaps some chlorine. Chlorine is still chlorine, and the symbol for chlorine is Cl. Then the atomic number from this serial number is 17. That means the innermost shell after nucleus will take 2 for this atom. The next one will take 8 as according to the rule. Then the last one will take 7. 2 plus 8 is 10. 10 plus 7 is 17. How many shells we have? 1, 2, 3. 3 shells. Okay. So remember our memory song, Hello, Hello, Little Baker brings certain news of flavor now. National manager always says perhaps some chlorine and killing cats. Now we are in national manager always says perhaps some chlorine. So Are, argon. That's number 18 element is argon. And then our symbol for argon is Ar all over the world. Then since it's number 18 here, the number of atomic number is 18. Number of electrons also is 18. Then the electronic configuration is now going to be innermost shell will take 2, next shell will take 8 according to the rule. Then the next shell will take 8, and that is all. The next shell cannot take, this one cannot take more than 8 because the rule says it can only take 2, 8, 8. So let's look at the next shell. Our number of shells is 1, 2, 3, 3. So let's go to the next element. Potassium. The song says killing. So there's no K in the spelling of potassium, but there's K as a symbol. Like sodium, potassium also, that K is taken from the Latin name, which is Kalium. Latin name Kalium. So K is taken from the Latin name of potassium, which is Kalium, and it's in number 19, meaning that it has atomic number 19. Electron number is now going to be 2, followed by the one that is 8. The maximum number of shell and of electron in this shell is going to be 8. Maximum number of electron in the third shell is going to be 8. Then it remains 1 because 8 plus 2 plus 8 is 10. 10 plus 8 is 18. Then plus 1, which is 19. So 1, 2, 3, 4 shells. Then the next one is now national manager always say pounds of glory are killing cats. This is number 20 in the series of the first 20 elements. Cats, meaning that it forms calcium, so that you can see it properly. Sorry, maybe okay, calcium. This is calcium element, calcium. So the symbol is Ca. Then the atomic number 20 is also 20. Now, how would the electron be distributed? The dynamo shell after the nucleus will take 2. The next one takes 8, as like we have been coming since we started. Then the next one takes 8 according to the rule. Then it remains 2. That's 2 plus 8 is 10, plus 8 is 18. Then the remaining 2 will now flip. So the cat is calcium. Remember, cat is not part of chemistry, but it's just a song that helps us to remember that Ca is the last element, which is calcium. The symbol for calcium is Ca, and number 20 means that it has atomic number 20, electrons 20. Now, this brings us to how the electrons will be distributed in the shells around the nucleus. According to the rule, the innermost shell will take 2, which is the maximum. Then the next shell takes 8, which is the maximum. The one that follows, which is the third shell, takes maximum 8 also. When you now say 2 plus 8 plus 8, that's 18. The remaining 2 will go to the fourth shell, and that means that calcium has 1, 2, 3, 4 shells. So this brings us to the end of our lecture on atom elements, which I taught previously, and also electronic configuration, the relationship between them, and most importantly, this song that I want you to learn as a science student. Learn this song. It will help you not only in basic science, it will help you also in chemistry, and it will just help you in so many ways, because you keep coming across these elements, the atomic number, and all those things for calculations, etc. So let me wrap it up like this. Let me sing the song again. Hello, hello, little baker, bring certain news of flavor now. National manager always says perhaps some chlorine and killing cats. 20 words in the song, 20 elements, and then you just follow it serially like that, and be able to remember the way your elements are arranged in the periodic table, the first 20 elements. Thank you for listening, and let's meet again in the next class. Thank you very much.